going to be solving another easy Leetcode question. Yeah, so I just wanted to say that the best thing about understanding linked list is if you can be able to visualize it. Visualization is half the problem when it comes to linked list. So to solve this problem, merge two sorted lists. Says you are given the head of two sorted lists, list 1 and list 2. Merge the two lists in a one sorted list, right? The list should be made by splicing together the nodes of the first two lists, and they're supposed to return the head of the merged linked list. So it's straightforward enough, right? You have the first one pointing to the second one, pointing to the fourth one, and then you have 1, 3, 4, and you're supposed to merge this list, but so that you merge it in a way that it's sorted. So your merge list is sorted. So you have 1, and then 2, and then 3, and then 4 before you have 4. So I am going to try to visualize that for us on my sketchpad here. So let's say we have two lists. So let's say we have 1 pointing to 2, which points to 3, right? And we have another list here. You have to always remember that when it comes to linked lists, it's linear. So you have to always move forward, right? And I told you that the way to move a list, if you remember in the last problem we solved, if you want to delete a node or delete a number in a list, all you have to do is to change where they to move the pointer essentially, right? So here what we want to do is want to clean this off and point it here, and clean this off, point it here and here, then and then this checks. Okay, this is obviously less, so point here, and the same goes here, right? And I mean, if you look at it that way, it's kind of like easier to understand. I think it's easier to understand anyway. Okay, so but what do we do when we have like a list that is shorter? So let's say we have 1, and then we have 3, and then we have 2, for instance. So obviously this one is shorter than this one, right? So what do we do in this case? We obviously want to cut this off here and point this to this one. So we have 1, 2. But what then happens to this one? Is it going to be lost? No, we're obviously going to have a way to keep track, right? Or we're going to have a way to keep track of this one that we are dissociating from the number. And when we are done going through the list, we want to point this one to the remaining sections, 3 in this case, right? So that's what we want to do with this problem. I would have solved the medium problem today, but I said, okay, let's just solve one more easy problem, and then before we move on to the medium ones, or we might solve more easy problems, who knows. Anyway, so yeah, so this problem here, it's really easy. All we have to do is to create a dummy node. So let's just call it dummy, and by creating new list node. Now if you remember, this function here generates a list node for us. Essentially that's just what it does, right? And it expects an argument. Now that we have this, let's call this variable merge, because this variable is the one that we're actually essentially going to keep adding things to, right? This merge variable is going to keep our new merge. If I don't know if I'm saying that right, but okay, yeah. So we'll call that dummy, and then what we want to do essentially is to return dummy.next. You know, I am a big fan of writing out your variables and then deciding what you want to return, because usually we forget this return statement right here, right? Okay, good. Yeah, good. Now, so when we have this, what we want to do, we want to keep checking between this value, list 1 value and list 2 value, and only appending the one that is less than the other to the merge, right? So we have 1, 2, 4 and 1, 3, 4. We check, okay, 1 and 1 which is less, it's the same. So, well, we can just go with 1, right? And that's fine. And then next time we move this pointer from here to 2, right? And now it's at 2, but this one is still at 1. So it's 1 and 2, which is less. 1 is less. So we go with 1 and then move the pointer to 3, right? And then now that we're at 3, we say, okay, 2 and 3, which is less. 2 is less. So we put 2 in our merge and move the pointer to 4. Now we have 3 and 4 to compare, right? Now we say between 3 and 4, which is less, 3 is less. So we put 3 into our merge and move our pointer to 4 at this point. At this point, we have 4 and 4, right? Now that we have 4 and 4, we check at the who is less. It says, well, they're the same. You can go with anyone you want. So we can try to go with this 4, or we can try to go with this 4. And then we add that 4 to the end. And then, but if you see, the problem is that we will forget, like we can't go back into the loop, because at this point, well, except it depends, right? The function I was about to write is going to check if I have both of them, and it's only going to run through the loop if I have both L1 and L2. Otherwise, it wouldn't. Right? So at this point, I won't have any more, like I won't have the 2. So I'm going to have to write another check at the end that checks for if I still have any remaining, like if I have L1 or L2 remaining, that's the list 1 or list 2 remaining, and then I'll just append it at the after the merge, and that's it. That's the solution right there. So okay, then so I'm just going to have a while that checks if I have list 1 and list 2, and only when I have list 1 and list 2 will it get into this loop, right? So what do I want to do here? Essentially, I just want to check if list 1 dot val. Now this is a very big I don't know why, but it's something that usually stumps me when I have to do comparison with linked list. I usually forget that, well, the list itself is like you're basically giving the head of the list, which contains like all the values in the list, right? And the next, and if you do list 1, if you check whether list 1 is less than list 2, it's not going to give you the correct, you're not going to be checking the correct thing, essentially, because you need to actually be checking the value of the list and not the node itself, right? So if list 1 dot value is less than list 2 dot value, then that tells us that we definitely want our merge dot next to be equal to list 1, right? Does this make sense? I hope this makes sense. And then yeah, so that's what we want, right? And but when we get our merge dot next to be equal to list 1, we definitely want to move the pointer on the list 1. So for instance, when we start it with let's go back to the sketchpad actually. So let's say we started with 1, right, 2, and then 4, right? And at this point we're saying, okay, you let's say we have also have 2 and 3 and 6, so at this point, where this pointer is here, so it's like, okay, so is 1 less than 2? It says, yeah, 1 is less than 2. So I'm like, okay, that's fine. I'm going to take 1 and put it into my merge dot next is going to be equal to 1. Remember, merge at this point is still just 0, but the next value here is now pointing to 1, right? It's pointing to 1. So because of that, I'm like, okay, great. Now that I have 1 here, I'm going to have to move this pointer to the second one, and I'm also going to have to move my merge from this point, from having this as the head to having this at the head. Otherwise, what I'm going to essentially be doing is just changing the next value for this 0, and that's not what I want, right? That's not what I want. I hope this makes sense. I really hope this makes sense. But if it doesn't make sense, You can just ask me in the comments and I'll try to explain it again. Anyway, so I have list1.value. Okay, yeah. So I have merge.next. So first I need to move my merge to now being equal to merge.next. So I don't always change the value of the next. I don't just change the value on the next pointer without essentially changing the merge. All right. So otherwise I'll just keep changing next value, and then when I return it's just going to have like merge.next, and it just always have two values. So I always have to move that pointer to the next one. Then I also need to move the pointer on the list one, right? So now list one is now going to be equal to list one dot next as well. Now, if if list one value is less than list two, what's the alternative? The alternative is that it's not, right? And it's not. So what could possibly happen? You know what? Actually, I'm going to be doing this all the time, so I'm just going to take it off, and I'm going to put it down here actually. Okay. So anyway, here I have mentioned next is going to be equal to list two, and then list two is going to be equal to list two dot next. And that's it. Now when we're done, it's possible that we still have like something trailing behind that we didn't account for. So for that reason, we'll just have to check if we still have list one. If we still have list one, then we need to say, okay, you know what, merge dot next is going to be equal to list one. That's whatever is remaining from this one. Otherwise, you know what, I'm just going to, instead of having another conditional statement here, I'm just going to check if I have list two, but then this will check this two times. So it's not possible to have both list one and list two at this point. You just either have list one or you have list two, right? So we could just do else here and have merge dot next be equal to list two, and we're returning them in dot next. So yeah, that's how you solve this problem. I'm just going to run this right here, use example test cases because I don't trust myself very well, and I submit that, and yeah, that's it. That's how you solve that problem. Yeah.